Welcome everybody to Unit 9, which is a big mix of all sorts of different stuff, basically applications of geometry. Um, so Lesson 1, we're going to talk about compound area. In order for us to do compound area, we need to know the area formulas, which there's the pink sheets that I pass out during class, or if you need to go on the website and look at the pink sheet, I believe it. I can't remember what it's called on the website at the moment, but if you look down towards Unit 9, it should be there somewhere. You need the formulas for area of squares, rectangles, rhombus, which is a parallelogram. Okay, those would all be under the same one. It has circle, it has trapezoid, it has triangle. So we need to know all those formulas. So if you have that sheet, get that out. It's going to be useful. I don't have one here, so I'm going to have to go from memory. What we're going to do with this lesson is we're going to cut up a shape into smaller, easier to use pieces, find the areas of each of those pieces, and then put them back together. Okay, so I'm going to use two different colors to help us out. Okay, first of all, we're going to cut this particular shape up. Now they give us some information here. And something I want to point out about this information is that lines they'll travel, okay, lengths. This 6 to 6 here, that length of 6 will also travel down here. So I can see that the length from here to here is going to be the same as it is up here. Okay, they don't tell us that they're parallel, but there are some things that we can assume with these drawings. Okay, so a length here would travel down. Now that's good news because right now this doesn't look like any general shape. But if I were to cut it, cut right across here, I would see that I have two shapes, both of them easy to work with. We have a rectangle, which is a type of parallelogram, and then we have a trapezoid. A length here of 6 and a length here of 6. Now I have all the pieces that I need for everything as well. So I'm going to label these as shape 1 and shape 2. I'll do 1 in green, I'll do shape 2 in blue. So the area of shape 1, we need to do length times width, which is 54. So we just found this to be 54 units, square units. Okay. Second shape is a trapezoid. Formula here is 1/2 height. So our height they show us here is 9 times base 1, which we know is 6, plus base 2. That would be 20. Half of 20 is 10 times 9 is 90. So we found this to be 90. Alright, so here's the thing. We want this whole shape. So we've got to now add together this piece and this piece. Whatever those areas were, add them together. That'll give us the area of the whole thing. So let's see, 54 plus 90 is 144. So the area is 144 square units. Similar problem. This is drawn not very well. I had a teacher in college that would probably yell at me if she saw this because of how sloppy it looks, and she'd probably say a computer could draw it way better. So I believe her in this example. Anyways, I see a couple of different shapes here. I see 3. So we're going to need 3 colors to work with. First of all, where do I see those shapes? Well, if I cut here to here, And from here to here, I've got half of a circle, which we'll deal with in a second. I've got this shape right here, which is some sort of rectangular shape, and then I got a triangle. So, circle, rectangular shape, and a triangle. So let's see, shape 1, area of a circle, half of a circle, so we need a half in there no matter what. Area of a circle is pi times radius, which is 4, squared. Let's see, that would be 16. Half of 16 is 8. So 8 pi for our first shape. Okay. We're going to keep that aside for a second. We'll deal with that in the calculator on its own. Second shape that we need to find is this middle shape, shape 2. It's a rectangle. Now here's the deal. The radius here is 4. So if I double that, we have a total length of 8, which we need because we need length times width. Okay? And then we have the final shape here, which is a triangle. 1/2 times our base, which is 6, times our height, which is 8. Let's see, half of 6 is 3, times 8 is 24. So we found each of these individually, 8 pi, 80, and 24. So now what we're going to do is add those all up. If you have a calculator that has the pi button on it, use that. If you don't, use 3.14, or you can use more decimals if you want to. Anyways, I have 8 pi plus 80 plus 24. And we come up with 129.13. Square units. All right. This one's a little bit more complex, just because of the way that it's drawn. We're going to have to do a little bit of calculations for some of these lengths. And I'm going to show you exactly what I'm talking about right now. Okay. If we start cutting this thing, we're going to notice that we have some pretty easy to work with shapes. Okay. I went straight across because now I have a rectangle here. And if I go straight across, I have another rectangle, and then I have a triangle. The problem is that I don't necessarily know how tall this rectangle is, or how wide the base of this triangle is. But I do know some total lengths. And as I mentioned at the beginning of this video, lengths are going to travel. Okay? That's actually really useful, because take the top for example. The length of this whole thing is worth 16. The length of this piece right here is worth 8. So if I were to take this 16 and travel it from here and here, travel it down and stop, that length of 16 is still equal, right? And if I want to know this piece right here, if the total is 16 and we get rid of the 8 that we know, it shows us that this piece right here is worth 8. Okay, that's going to work here as well. This 10, this 5, and this mystery height. Okay, this mystery height, we're not sure. In fact, let me get a different color. This mystery height, we're not sure, but we do know that it goes down like that, right? It's going to be equal from here to here. This whole length from here over is worth 10, and we don't know this one. So if we take 10, we subtract the piece that we know, it's going to give us the piece that we don't know, which is 5. And because this right here travels, it's congruent to this piece here, so now we know the length as 5. We've got some good stuff. We also know that this length here of 8, it can travel down here, and we now have a length down here of 8 as well. So I did a lot of little shifty things there, but it wasn't anything not allowed, right? I just looked at the lengths, kind of imagined them moving, thought about the total length, did a little bit of quick subtraction. Okay, that's how we find the missing parts. And you're going to have some problems like that coming up, so hopefully you remember that technique. So let's find this first one, the rectangle. We have a base of 16 times a height of 5, which gives us 80. The second piece right here, we have a base of 8 times a height of 5, which gives us 40. And then finally, triangle. So we have half of the base, which is 8, times the height, which is 4, which gives us 16. Total area, we want to add 80 and 40 and 16, which is 136 square units. So we continued with the idea of cutting up the shape, but this time we had to use a little bit of subtraction with the pieces that we knew throughout to help us. So I believe there are 2 problems for you to try on your own. I'm going to suggest that you take a second and draw them out first, and be very careful with your drawings, okay? Be very careful with your drawings. Take your time, make sure that you label them correct. So I'm going to kind of go like this. There's nothing else down here. This just comes to a point right here. So pause the video and you can do both of these, and then resume when you're ready to check both problems. Okay. We'll start with this one. This one says find the area to the nearest hundredth. That's because you're going to have to use pi, because we have this half circle here. It's not really drawn very well again, but that's alright. I'm not critiquing anybody's artwork here. So, right here, we have this half circle. Okay, so that's part of it. Then what we could also do is go here straight down and chop off what looks like a nose and have a second shape, which is great, but we need to know how long this piece is. Well, this was worth 20, so this whole length from here to here should be the same length, 20. So 20, and we get rid of the 4 that we know, that tells us that this is worth 16. So now I have enough information that I can find each piece. Let's find the area of the circle first. It's going to be half of pi times radius squared. Let's see, that would be 36. Half of 36 would be 18 pi. second piece that we need. I'm going to do the giant rectangle here as the second piece. Well, let's see. Here the radius is 6. That makes a full length of 12. That full length here and here, those should be the same. So 20 by 12. Actually, it didn't really matter that I did that. Anyways, it's going to be the same thing. It's going to be 240. And then last, this triangle here, half base, which would be 16 times the height of 8. Let's see, half of 16 is 8. 8 times 8 is 64. Alright, so we need 16 pi plus, oops, I'm sorry, 18 rather, pi plus 240 plus 64. My calculator shows 360.54. 360.54. Alright, and we got one final one to take a look at. Again, you should have paused the video and tried this one already, so we're just going to dive right into finding the solution. Now, you could have chopped this up into different pieces than what I'm going to do. I'm going to do these 3 pieces. Here and here. I have already seen that I could do this as 2 trapezoids, but I'm not going to. I'm just going to leave it alone and do it as 3 pieces. Okay. Let's see. They give us 10 here to here. That's going to travel over, which tells me that this is 10, which traveling over gives me that this piece is 10. From here over is 22. This 12 coming up tells me that 22 minus 12 leaves me with this length here as 10. Alright, I think the only other thing we need would be, let's see, 4, 10, and 6. That would be a full length here of 20. So, let's do this trapezoid first. It's going to be half height, which is 4, times base 1 plus base 2. 10 and 20 is 30, so we get an area of 60 units for this first trapezoid here. Second, 12 by 10, which is 120. And then last, we have half base times height. Now we've got to add these together. 60 and 120 and 50. Oops, area equals 60 plus 120 plus 50. Area equals 230 square units. Compound area. Pretty easy to do. Cut the shapes up into easier to use pieces. And then add those pieces back together. That's it for that video. We got a couple more lessons to go in this unit, and then we're going to be done with geometry. A couple more to go. See you at the next one.